Ever wondered how systems spot tiny objects in the dark? Like finding a firefly in a storm or a drone hidden in a vast landscape. That's the challenge of infrared small target detection, identifying faint, minuscule signals buried in complex scenes. Today, we're diving into the cutting-edge techniques scientists use to solve this problem, and how they're redefining the boundaries of computer vision. The core of the solution lies in breaking the problem into smaller, more intelligent steps. Imagine searching for a needle in a haystack. You'd scan the whole area first, then zoom in on suspicious spots. Modern systems do the same, using advanced algorithms to analyze images at multiple scales, prioritizing regions most likely to contain targets. A major breakthrough is feature pyramid networks. Think of them as visual magnifying glasses that examine images at varying resolutions. Papers like NS-FPN 2019 and EfficientDet 2020 demonstrate how these networks adaptively highlight details, making small targets easier to detect. But here's where it gets even smarter: attention mechanisms. Networks like Dense Nested Attention 2022 and SCTransNet 2024 train models to focus on relevant image regions, effectively ignoring background noise. But infrared images are notoriously noisy, like trying to read a book in a room with flickering lights and TV static. Tiny targets such as missiles or humans are often drowned in this noise. Traditional methods amplify signals, but also boost the static. That's where NS-FPN steps in, offering a revolutionary approach. NS-FPN isn't just another algorithm, it's a clever fusion of old ideas with new tricks. It begins by decomposing images into frequency components, much like separating a song into high and low notes. High frequencies hold fine details, while low frequencies reveal the big picture. The NS-FPN team discovered that noise causing false alarms resides in those high frequencies. They built two cleaning tools. The first is the low-frequency Guided Feature Purification, LFP, module. Imagine searching for a hidden treasure in a muddy pond. LFP uses the blurry, low-frequency blueprint of the pond to filter out random silt and mud, noise, revealing the real treasure. Then there's the spiral-aware feature sampling, SFS, module. Think of it as a spotlight that spirals across the image, zeroing in on targets. Instead of random sampling, it mimics how our eyes track moving objects, making it exceptionally good at spotting tiny, shape-consistent targets like drones or people without getting distracted by the background. The results: NS-FPN slashes false alarms by up to 80%, while maintaining 95% detection accuracy, like cutting security system false alarms without missing real threats. It's also lightweight, making it ideal for power-constrained devices like drones or night vision gear. Why does this matter? From military surveillance to search and rescue missions, better infrared detection translates to safer, smarter technology. NS-FPN proves that combining classic techniques with creative problem-solving can turn a chaotic, noisy scene into a clear, actionable picture. Thanks for watching. If you're curious about how AI tackles real-world challenges, hit that subscribe button. And drop a like if you're as fascinated by the intersection of vision and noise as we are. See you next time.